Welcome to the Project Management Prepcast, helping you prepare for the PMP exam. Here's your instructor, Cornelius Fichtner.
Welcome back. I'm your instructor Cornelius Fichtner, and this is part 2 of our lesson of control quality. In part 1 we gave you an overview of the control quality process and introduced and defined important terms for you. And now here in part 2 we'll focus on the process inputs, tools and techniques and outputs, as well as a lesson review. We begin briefly with the ITTO overview from the PMBOK guide. When you look at this, 8 inputs, 4 tools and techniques, 8 outputs, this is going to take some time to get through. So we have 8 inputs to this process. 6 of these we're going to take a look at, and 2 of them we're going to skip. Here are the 6 that we will be looking at in more detail. Quality metrics, quality checklists, work performance data, approved change requests, deliverables, and the organizational process assets. And the 2 inputs we are going to skip are the project management plan. It contains the quality management plan, which we use here in this process, and it provides a description of how quality control will be accomplished on the project. And the second one are the project documents, which contain things like agreements, quality audit reports with corrective action plans, or training plans and assessments of effectiveness. Quality metrics are an output of the plan quality management process. Quality metrics are needed in this process here so that we can measure the results against the planned metrics. Quality metrics are used to compare whether the work results meet the quality specifications. This is where we would find the upper and lower control limits for the weight of our screws. Some examples of quality metrics include function points, mean time between failure, and mean time to repair. Let's also take a quick look at the difference between metrics, control limits, and measurements. Metrics are a set of measurements that quantify results. Performance metrics quantify the unit performance. Project metrics tell you whether the project is meeting its goals. Business metrics define the business progress in measurable terms. For example, we want to achieve a market share of 15 to 20%. A limit, on the other hand, is the point, edge, or line beyond which something cannot or may not proceed. For instance, in our screw example, the screws may not weigh more than 3.9 grams. A measurement, then, is the dimension, quantity, or capacity determined by measuring. Or, in other words, a measurement is an actual value, while metrics and limits are planned values. Our next input are the quality checklists. Checklists are structured lists used to verify if required steps have been performed. Quality checklists show the steps taken to achieve quality on the product. They help in verifying that the work on the project and its deliverables meet the established requirements. Checklists assist in assessing product conformance to quality, and quality checklists make sure that the deliverables are complete and adhere to the mandatory attributes. Our next input, the work performance data, are the observations and measurements identified while the project work activities are being performed. The work performance data can shed light on the current state of the deliverable and where it should be due to the data being viewed at its lowest level of detail. This is important because now we understand that the measurements are the actual values that were achieved on the project. Work performance data becomes really interesting when you begin to compare them to planned values, the metrics and limits. Data is obtained through work execution and then forwarded to the controlling processes, in this case control quality, for additional analysis. work performance data is used to compare measurements to planned values. And this is how you identify if you've reached your cost and schedule targets and if your deliverables are produced according to standards. Some examples of work performance data include planned versus actual, work completed, start and finish, schedule activity dates, or cost performance. Change requests are approved in the integrated change control process and then implemented via an executing process. Here in the control quality process, we want them as inputs to make sure everything was done properly. So what we do is we first look at our change log. In here we will see that some changes will have been approved and some changes will not have been approved to be implemented. And of course we will then look at the approved changes, and later on in the process we can see whether or not timely implementation was done. We see defect repair, we see revised work and methods and schedules. So this is the input that we get from the change log, from the individual approved change requests. And here in control quality, we'll get to the tool and technique in just a minute. We'll make sure that it was all done properly. The next input to control quality are the deliverables. They are the unique and verifiable products or results from the project. Deliverables are a primary input to the control quality process, and having them as such is the primary focus, really, of the process, because without deliverables as an input, we would not be able to measure them and compare them against the plan now, would we? And lastly, the organizational process assets. As we have seen in another example, control quality doesn't just measure the deliverables that we give to our customers. We also measure other ancillary results. For instance, your company may have a procedure in place that requires every hour on your project must be logged in a specific time tracking tool. This would be defined in a policy. And here in control quality, we would now use this policy as a basis to verify if really all hours have been logged accordingly. We are moving on to the tools and techniques here in the control quality process. In total, there are 10 tools and techniques, but the first 7, they are grouped together into one as the 7 basic quality tools. So that covers the first 7, which means we have 3 left: statistical sampling, inspection, and approved change requests review. Our first input, the 7 basic quality tools, also known as the 7 QC tools, are statistical tools used to solve quality-related issues in the context of the plan, do, check, act cycle. They are the cause and effect diagrams, flowcharts, check sheets, Pareto diagrams, histograms, control charts, as well as scatter diagrams. Luckily for us, we have a separate lesson in which we focus on these tools, so we don't have to review them right now, and we're moving on to the next tool and technique. Statistical sampling is a powerful tool where a random sample of the population of interest is selected for inspection. A sample is used rather than measuring every single item in the entire population. Sample frequency and size should be decided during the plan quality management process to factor in the cost of quality. By doing sampling properly, you can dramatically reduce the number of measurements that you need to take. If you're producing 1 million screws and you measure 1 million of them, that's a lot of work. But if you only measure every 10,000th screw that you produce, that's 10,000 times less. The tool of inspection is exactly what it sounds like. We talked about it earlier in this lesson, but let's revisit it again in a bit more detail. Inspection is the testing of a work product to determine if it conforms to the documented standards. The results of an inspection typically include measurements, and it may be conducted at any level. For instance, you can inspect the results of a single activity or of the final product of your project. By performing inspection, you make sure that you catch the errors that have occurred before they reach the hands of the customer, so that faulty machinery or defective software never gets sold to the customer. Inspections are also used to verify defect repairs. Corrective action is taken to fix a deliverable or process, and then it is re-inspected. So we had the approved change requests as an input to this process. And I already sort of hinted then when we reviewed them at what we're actually doing here. We're reviewing, we're making sure that they were implemented properly. It is very important that all change requests are reviewed after they have been implemented. This is done to verify that they were first of all approved to be implemented, and second, that they were implemented properly. And that was it for the review of our 10 tools and techniques. That was quick. So we're moving on to the outputs, and we have 8 of them here. We have the quality control measurements, validated changes, verified deliverables, work performance information, change requests, organizational process asset updates, project management plan updates, and project document updates. I'll promise you this will take a bit longer. Our first output, the quality control measurements, are the results of the control quality activities. These are the results that we documented. As the control quality process is performed, important measurements of quality levels and compliance are a normal output. Remember the plan, do, check, act cycle? Well, these measurements are an output of the check portion of this cycle, and we now will hand them back to be acted upon, and then they may be used for replanning. Validated changes are our second output. Any items that are changed or repaired are inspected and will either be deemed acceptable or they will be rejected. Those items that are rejected, they may require rework, and this output can of course lead also to updates in the project management plan. It is not difficult to see that the PMBOK guide is very circular and iterative. Processes get performed not just once, but again and again over time. That is why once we issue a recommended defect repair, this recommendation will then hopefully be approved in the integrated change control process. From there, the repair will then be taken care of as part of the direct and manage project work process, where the repaired deliverable will be handed back here into this process for re-inspection. And it is at this point in the process that the deliverable can be validated, and that is what the output of validated changes is all about. We have validated that the change was implemented properly. And so we have come to the output called verified deliverables. Yes, one goal of control quality is to ensure that our deliverables do in fact meet the quality standards that we have defined. The control quality process determines deliverable correctness. These verified deliverables, they are then an input to the validate scope process, which we cover, of course, in our lessons in the scope management module. The next output is work performance information, which contains the performance data that is collected from the many of the controlling processes. It is analyzed and integrated relative to the areas that it is associated with. Some examples include project requirement fulfillment information such as causes for rejection, rework, and process adjustments. The PMBOK guide defines our next output, a change request, as a formal proposal to modify any document, deliverable, or baseline. The control quality process involves monitoring specific project results to determine whether or not they comply with the defined quality standards. If not, then recommended corrective or preventive actions or a defect repair must be undertaken so that the deliverable is in compliance. Whatever form or corrections take place require a change to the project management plan, so a change request should be issued in accordance with the Perform Integrated Change Control process, which is covered in more detail in that particular lesson. While defect repair and corrective actions will fix a process in hindsight, we may very likely come across the situation where our quality control measurements show us a negative trend. This is something that cannot be allowed to continue. We have to fix this. A negative trend is usually a bad thing. The goal is to always deliver according to specifications, because quality is conformance to requirements. So we want to prevent any deviations, which is why we may also issue change requests with preventive actions. With these, we will forestall any issues that we might run into as the project progresses. And then finally, we have 3 outputs that are all about updates. There are elements of the organizational process assets that may need updating during the control quality process. These could be completed checklists. When checklists are used, completed ones become part of project documents, or lessons learned documentation. Lessons learned from control quality are documented and become historical data for the project and the organization. We have project management plan updates. These can result also from this process here. For example, the quality management plan may need to be updated. Changes to the quality policy, for example, or the process improvement plan, where activities are streamlined and improved. And finally, we also have updates to the project documents. Here we may update quality standards or agreements, because as we went through this process here, we have gained additional insights, allowing us now to add more value or fix inconsistencies in these documents. Let's review. The control quality process is a process of monitoring and recording the results of activities that have been carried out on the project. The primary input to this process? Deliverables. Without the deliverables, we couldn't measure anything. Control limits are then statistically stable process boundaries of what the process should be doing all along. Results within those boundaries are set to be in control, and change requests are necessary for recommended corrective or preventive actions or defect repair. And here is a sample exam question that you may find in an online exam simulator. The project is going through control quality. Which of the following is a key tool to validate defect repairs? Is it A, the quality management plan, B, benchmarking, C, inspection, or is it D, rework? I'll give you a second here to think about this. The answer is, of course, it is C, inspection. Inspection is a key tool in control quality, as it is used to determine if the product conforms to the documented standards, and it provides validation that the product was built as intended and without defect repair needs. The quality management plan is used to establish the standards and how to achieve them. Benchmarking is a tool used in the Perform Quality Assurance process, and rework is only necessary when products are not built correctly. Before we go, here is a PMP exam tip for you, or rather, it's something to ponder on, and that is the question: should you tell your co-workers the date on which you're going to take the PMP exam? Well, this really depends on you personally. If the added pressure of your co-workers wishing you good luck or break a leg is something that might make you nervous, then don't tell them. But do go ahead and instead take a day off and ask your supervisor not to let anyone know why you are gone. That way you don't get to feel their anticipation for you to go to that exam and pass the exam. Well, but then again, this may not bother you, and you may even see that this is an additional challenge. Well, think about it yourself and decide yourself. And this concludes our look at the control quality process. So Justine and I say goodbye.
Bonne chance, mes amis.
Now wait a minute, that wasn't Justine, that was Kevin. Justine, are you still here? Hello, Justine?
Talk to you later.
Ah, thank you. Until next time.